Hey there everyone, welcome back to Crash Course, and today we're diving into the fascinating world of web APIs. You know how we love exploring the interconnected world of the internet, and APIs are like the secret sauce that makes it all work. In simple terms, a web API is a messenger that allows different applications to talk to each other. Imagine you're ordering food online. You're using an app on your phone, right? That app interacts with the restaurant system through an API. It's how your order gets sent to the kitchen and how you see when your food is on its way. Web APIs are the backbone of countless online services we use every day. From social media integrations to online banking, APIs are quietly working behind the scenes, making our digital lives smoother and more efficient. Now, building a robust and reliable web API involves understanding some key concepts, and that's exactly what we'll be exploring today. Get ready to unlock the power of error handling, CORS, filters, and dependency injection. Let's go! All right, folks, let's talk about something crucial in web API development: error handling. We've all encountered errors while browsing the web, those dreaded 404 not found pages or the occasional 500 internal server error. In the world of web APIs, errors can arise from various situations. Some common culprits include validation failures. Imagine someone trying to create an account without entering a valid email address. That's a validation error. Authorization issues. This happens when someone tries to access something they're not allowed to see. Think of it like trying to sneak into a concert without a ticket. Internal server errors. These are the trickiest ones, often caused by unexpected problems within the server itself. Now, the good news is that we can handle these errors gracefully using something called HTTP status codes. Remember those 404 and 500 codes we talked about? Those are just two examples of a not found. When a user requests something that doesn't exist, like a product that's no longer available, we can use the not found method to return a 404 not found response, internal server error. For those unexpected server hiccups, the internal server error method comes to the rescue, sending back a 500 internal server error code. Now, imagine having to handle errors separately in every single action of our API. That would get tedious quickly. Thankfully, Web API provides a handy tool called exception filters. These filters allow us to centralize our error handling logic, making our code cleaner and more maintainable. But wait, there's more. Action filters give us even more control over our API's behavior. They allow us to execute code before and after an action is executed. Need to log requests, validate inputs, or even modify responses. Action filters are here to help. Hold on tight, because we're about to tackle a concept that often trips up even seasoned developers' CORS or cross-origin resource sharing. Understanding CORS and its importance. Imagine you're hosting your awesome web API on one domain, and your super cool web application, which uses that API, is hosted on a different domain. By default, browsers have security measures in place to prevent scripts from one domain from accessing resources from another domain. This is where CORS comes in. CORS is like a set of rules that browsers follow to determine if they should allow cross-origin requests. It's essential for enabling secure communication between your web application and your web API, even if they're hosted on different domains. Enabling CORS in web API using. Now, the good news is that enabling CORS in our web API is surprisingly straightforward, thanks to the library. With just a few lines of code, we can configure our API to allow requests from specific origins or even open it up to requests from any origin. Remember, enabling CORS is crucial for modern web applications that rely on APIs from different domains. The role of web API filters. All right, let's dive into the world of web API filters. These handy tools act like middleware, intercepting requests and responses, giving us a powerful way to customize our API's behavior. What are filters and why use them? Think of filters as checkpoints or gates in your API's pipeline. They can examine incoming requests, modify outgoing responses, log important information, and even short-circuit the entire request-response cycle if needed. Why are they so great? Well, filters promote code reuse, improve maintainability, and help us keep our API code clean and organized. Illustrative example, a simple logging filter. Let's say we want to log every request that hits our API. We could write logging code in each action method, but that would be repetitive and error-prone. Instead, we can create a logging filter that automatically logs request details before each action is executed. Public class log request filter, action filter attribute, public override void. On action executing, hatipaction context action context, //log, the request details here //. You can access request headers, query parameters, etc. By applying this filter to our controllers or actions, we can effortlessly log all incoming requests without cluttering our action methods. Section 5, Types of Web API Filters. Now that we've seen the power of Web API filters, let's explore the different types available. Authorization filters, controlling access to actions. As the name suggests, authorization filters are responsible for controlling access to our API's actions. They act as security guards, verifying if a user is authorized to perform a particular action. Action filters, modifying behavior before and after actions. Action filters, as we saw earlier, allow us to execute code before and after an action is executed. They're incredibly versatile, enabling us to handle cross-cutting concerns such as logging, caching, and input validation. Exception filters, gracefully handling exceptions. Remember those unexpected errors we talked about? Exception filters are our secret weapon for handling them gracefully. They allow us to catch exceptions thrown during the execution of an action and return appropriate error responses to the client. Result filters, manipulating action results. Last but not least, we have result filters. These filters kick in after an action is executed successfully and allow us to manipulate the result before it's sent back to the client. We can use them to format data, add headers, or even log response details. Section 6, Dependency Injection, DI, in Web API. All right, buckle up as we dive into the world of dependency injection, DI. DI might sound intimidating at first, but trust me, it's a game changer for building maintainable and testable web APIs. The concept of dependency injection. Imagine you have a class like a controller that relies on other classes to do its job. These other classes are called dependencies. DI is a design pattern that allows us to provide these dependencies to a class from the outside, rather than having the class create them itself. Benefits of using DI in web API development. So why is DI so awesome? Well, it makes our code more testable, more maintainable, and more reusable. We can easily swap out real dependencies with mock objects during testing. Changes in one part of our code are less likely to break other parts, and we can easily reuse our classes in different parts of our application. Implementing DI, injecting services into controllers. Now, the cool part is that Web API makes implementing DI incredibly easy. We can use a DI container like AutoFac or the built-in ASP.NET Core DI container to register our dependencies and inject them into our controllers through constructor injection. Public class myController, API controller, private readily IMyService_myService, public myController, IMyService underscore myService equals sign myService / action methods that use underscore myService. By injecting through the constructor, our controller doesn't need to know how to create an instance of. The DI container takes care of that for us. Section 7, Conclusion. bringing it all together. Congratulations, everyone. We've covered a lot of ground today, exploring essential concepts for mastering web API development. We've learned about handling errors gracefully using HTTP status codes, exception filters, and action filters, enabling secure cross-origin communication with CORS, leveraging the power of filters for cross-cutting concerns and code organization, and embracing dependency injection for testable, maintainable, and reusable code. By understanding and applying these concepts, we can build robust, reliable, and scalable web APIs that power the next generation of web applications. Keep experimenting, keep learning, and keep building amazing things with Web API.